All right, 4.9. This is the last lesson in chapter 4. Woohoo! This talks about qualitative graphs. So qualitative based on quality. So it's talking about the quality of the picture of the graph, because they may not give you numbers to represent the situation. They're just going to give you the graph. Okay? So if they don't give you the numbers, you have to either draw the graph based upon a situation or interpret the situation based upon the graph. So let's look at this. First one. The graph at the right displays the water level in a bathtub. Describe the change in the water level over time. So here's time. Here's your water level. What's happening here? Well, you're filling up the bathtub at a steady rate, right? That's what that is, a steady rate. The water isn't like going real trickling and then full blast and then trickling. It's a steady rate. Once you get to the level of water desired, you turn it off, right? So the water level stays the same for the course of the bath. And then whenever you're done, you drain it and it goes out the drain at a steady rate. That's what that looks like. That's the picture. That's what you're going to talk about. So if I ask you to describe that graph in words, that's what you would tell me. Just what I just said. It fills up at a steady rate. Once it gets full, you turn it off. The level of water stays the same until you're done. You drain it. It goes out at a steady rate until there's no water left. All right. So I want you to now try one. Underneath got it. Go ahead and pause it and try A and B. All right. Back with me on got it. I want you to describe this. So this is the picture. Talks about the time of day. So as the day goes on, this is what happens to the temperature. So what would you say? You would say that it starts to increase. Now, this doesn't necessarily mean that temperature is 0. That's not what it's saying. It's just saying that wherever it starts from, the temperature goes up. Not necessarily a steady rate, because as you can see, there's a little bit of a curve that goes with this. But it does increase until what? Midday, maybe? And it hits its maximum temperature. And then it will start to decrease, not necessarily at a steady rate, but it will decrease nonetheless. That's what you are going to write out for me. On B, the graph represents revenue from a local clothing store. Describe the sales over time. So, over time, as time goes on, in general, their sales are going up, right? But there was one little period about right there where sales declined, and then they went back up, and then it looks like they kind of stalled out a little bit. And they're just a little flat, and then they started to increase again. So overall, they are increasing, but there is 2 points in the sales that they would actually decrease just a little bit, or they would remain the same. So again, notice that nowhere in here am I asking you to work out a rate of change, find the slope, find the intercept. So it's kind of a nice change, right? Do these kind of things, but you are going to have to write. So what? Writing in math? What kind of crazy talk is that? Well, that's what you have to do on the ISET test and the new Park assessment that's coming out. You're going to have to analyze situations and write things out. So this is good practice for that. Lucky, lucky, lucky children. All right, let's move on. Top of the next page talks about sketching qualitative graphs. So now they're going to give you the situation, and you have to make the graph. So a tennis ball is dropped onto the floor. Each successive bounce, it rebounds to a height less than its previous bounce height until it comes to a rest on the floor. Sketch the qualitative graph to represent the situation. Now, all of that, nobody, oh my gosh, I don't even understand that. Think about it. If you were to be on top of a ladder and you drop a tennis ball, it's going to bounce, come back up, but does it ever come right back up to where it was? No, it gets successfully lower and lower and lower and lower. That's what this graph is. So if you were going to graph this and you were going to write this out, first of all, notice that the ball does not start down here at the bottom, right? Were you laying on the floor and threw it up? No, you were on a ladder. I'm assuming you're on a ladder. Did we say that? Well, we're assuming that we're on a ladder. Maybe you're just really tall. And so you're going to drop it. Whenever you drop it, it's going to go down, come back up. Now, notice, why are these curves even? Kind of even looks like a ball bouncing on the floor, right? But as time, this is time still moving on. So it's not going to look like this, because they are going to gradually go up and gradually come down. So they are more like the actual ball would look. Okay, so make sure that your graph actually fits the situation that we're talking about here. Look at 3. A child swings on a swing. Sketch a qualitative graph to represent the situation. Okay, so we've got the axis right here, both of them, distance from the ground and time. All right, I forgot to talk about that at the first one. You will have to draw your own, and you do need to label them. Anytime you draw a graph like that, you do need to label. So this would be time, this would be the distance. So here is your time. As time goes on, usually you would put time on the x, and this is going to be your distance from the ground. So now, again, notice that the swing is not down here, because usually swings don't sit right on the ground, right? I mean, your feet usually touch the ground when you're on them, but the swing is usually up. So make sure you're starting from a reasonable distance. Doubt you're going to have a swing all the way up here. Okay? So the swing distance from the ground, you're going to go up, and then you come back down, and then you go up, and then you come back down, and then you go up. Now, notice this is a little bit higher. Why are each of these peaks a little higher? Well, think about it. Whenever you start to swing and you start to go, I'm going to draw it just like this. So you start to go, you're about here, and then you pump your legs, you go back up, and then here you go back up. And each time you just get progressively a little higher and a little higher. Now, there is a maximum height, right? I mean, you're not going to like flip over the top. So whenever you've got this, you're going to get just a little higher next time, and then a little higher next time, until you gradually come to a stop. Okay, so now, does this mean they fell off? No, it just means that they stopped. That's all they got. All right, let's move on. Okay, I want you to try it. Under got it. A car is traveling at a constant speed. A car slows down steadily and comes to a rest at a stoplight. Sketch a qualitative graph to represent this situation. So we would first need to write the axes that go with this. So whenever you're talking about this, you're talking about time, which we usually put down here on the bottom, right? So time is your x, and this is your speed. So if the car is traveling at a constant speed, does it say he starts and then gets to a constant speed? No, you're getting into this situation that he's already traveling at a constant speed. Now this is supposed to be a straight line, but the marker's not really helping me out here. So constant speed, he's not increasing, not decreasing, that's it. And then whenever he comes to rest at a stoplight. So if here's a stoplight, you're traveling on, do you just stop and brake it? No, we're not slamming on the brakes. Is you steadily come to a rest. Steadily come to a rest. Steadily come to a rest. Now, we should probably go ahead and extend that out a little bit more. So constant speed, steadily come to a rest as you apply your brakes, and you are at a stoplight. Okay, so again, these are just some things that you're just going to have to think about. You're just going to have to use your brain and see what we got going on here. Okay, so just going through a couple more just to make sure that you've got what you got going on here, and we can think about how you need to think. So the graph below displays the height of an airplane. Describe the change in the airplane's height over time. So what would you write out? You would write out it starts at takeoff, increases its height at a constant rate, gets to the flying level, it stays there until it starts its descent into the airport, and it comes down at a steady rate. That's what you've got. Number 2, Jamal purchased the same number of action figures daily for 1 week. What does that mean? Same number? It means there's going to be a constant rate. Over the next week, he sold most of them on the internet. Sketch a qualitative graph to represent the situation. So you've got your number of action figures. I'm just going to abbreviate them over here. And then we've got our time here. Time. So it says he acquired them daily for 1 week. So it's going to be at a constant rate. And then it says he sold most of them. So he sold most of them. Now, should he get back down to 0? No, because he didn't sell all of them. He sold most of them. So just make sure it goes over halfway back down. Okay. We'll try maybe one more. Let's look at number 3. We had Jamal last time. Now it's Tamara. Rides her bicycle at a steady rate. She coasts downhill, which increases her speed at increasing rates. Sketch the qualitative graph to represent the situation. So again, you need to first put your titles. This would be time. Here's speed. Now you're talking about she's riding her bicycle at a steady rate. So she's not going at 0, right? I mean, she's got a rate, so it's somewhere in here. And then as she goes downhill, her speed increases. So it looks like that. Now, in your head, if you think, okay, she's going downhill, it's going to look something like that. But what does that mean? That means that her speed is decreasing. So as you go down a hill, does your speed decrease? No, you speed up. So this, wrong, this, correct. Okay, so with that, that concludes the lesson. We're a little shorter than normal, so that's good for you, right? There's not any crazy formulas to figure out. There's no numbers to get positives and negatives wrong. Can't really add or subtract wrong. You just have to think and be able to draw. So I'm not asking you to draw the Mona Lisa. Just draw some figures, draw some sketches that go with the information that's there. Please, please, please remember to put your titles on the axes. Okay? So happy drawing. Good luck.